Let's start the revision. Uh, Today we will talk about strings and structures in C++. Strings are a sequence of characters enclosed in double quotation, but these strings are again divided into into two or several categories. One is called a C string, another one is called string class. So C strings is the old version of strings in C++, and the new advanced version is C string class. So let's talk about first of all about the C string or C style string. C style strings is any combination of characters enclosed in double quotation, but not the point that every C style string is terminated by null character, meaning to say the last character must be a null character, and null character is this one. Okay, so C style string, uh, one we call string literal. So string literal is any string which is enclosed in double quotation, and the system will automatically append at the end then the null character. Second category is character array. Character array, you know that array can be of any type, but when array become a character array, so then we can initialize the character array in two ways, like character array, data type, name of array, brackets, and then we provide the value in double quotation. Okay, in case in the form of a string, so it become a character array. So the system automatically put the null character at the end of that. Or second way, we can do manually by ourselves, like this, that character array, and then we provide the each character in the form of character. So not the point, the character must be enclosed in a single quotes. So every character is individually enclosed in single quote, and at the end we provide the null character. So meaning to say the C style strings must be terminated by null character. Okay, null character, because this is the only way that the system understand that the string ends here. Okay, and this is the end of the string, otherwise the computer don't know and the compiler don't know. So this is mm, one type of string, and actually this is the big drawbacks that computer only understand its end and can it's add by the null character. Okay, and there are some disadvantages of these C style strings. First of all, the C style string array don't know about its size. In any other languages and in any other type of arrays, every array know there is a method, there is a function like length of array, but in C style string the array don't know about its size. So meaning to say, when you are processing, when you are accessing the elements of array, actually you will have to manually remember the size of array, otherwise there will be a problem. Another thing is that the functions provided by the C string, that functions like strcopy or strcat, these functions you will have to memorize, and you will have to know and memorize the number of argument, the type of argument, the order of argument, which makes a bit difficult the usage of this type of string. So, another drawback is that these arrays, the C-style string arrays, are fixed. Fixed means that if the size is 10, then there will be only 10. If 20, then will be 20. It cannot automatically increase and it cannot automatically decrease. So this is why it's not dynamic. It is a fixed size array. This is another limitation of a C-style string. Another limitation is one by half by one bugs. Half by one bugs means that you know that every C-style string, the last character must be a null character. So the string there at the end will be one extra null character. So if the string is 10 character, then the overall sum will become 11 because of the extra one. If it is 20, then mm, it will be 21. So the actual string is always off by 1, meaning to say, you see, like total size is 11, but the actual size is actually 10. Okay, that the 11th one is the null character. So this also makes sometimes confusion, and you will have to remember by yourself. Okay, so to fix all these issues, the new advanced version of string in C++ is string class. Okay, so what if we could fix those advantages? So actually this string class is solving all these issues that we discussed in the previous slide. So in this one, you see, it's quite easy. We will use the class name as a data type string, and then you can create any type of variable. You can declare any type of any variable like string, my string, string name, string address, whatever. Okay, so this is the way of declaration. If you want to initialize at the same time, then you can use the string constructor, and it will be like this, like string and the name of variable, and in a brackets you can provide any value. Then this string class has so many useful and easy to remember functionality. So for example, if you want to compare two strings, you see, just use the normal comparison operator like my str and name2. So you see, just quite easy, not like the C style string, the normal comparison operator. So you can compare the operator, the two strings, and then the system will compare character by character. So if they are 100% identical, then this message will display. Okay, in the same way, compare using the less than operator. You see, it's quite looks natural. Okay, and so this is the point that it become easy to remember, easy to access, and easy to use. So string class is the same. In a string class is also strings, and string is a sequence of characters enclosed in double quotation. But the way that the system is dealing, the way that how the system is storing them in a memory and then accessing, and the type of functions and the operators that string class provides, that are too advanced, too easy, and easy to remember, easy to use, and looks natural. Therefore, overall, the string class makes the usage of string easy as compared to C style string. Okay, so our next topic is structure. Now, what is structure and why we need it? Before that, if we look at this at one problem, there is one actually very common problem that, for example, if we want to store data, especially too much data, then actually variables cannot store. For example, one variable int or character, so it can only store one value. So if we want to store many values, then we use array. Okay, then in array we can store many values, but you know again that in array only one type of data can be stored. For example, the array may be int, or the array may be float, or the array may be character. We cannot mix different type of values into one array. Similarly, string also we cannot use to store many values, because string only handle string values. It cannot handle float, double or boolean values. So you see, all these built-in data types are dealing with one value or with one type of value. But in the real life, all the things that we are dealing with, for example, any a real life object, for example, students, mobile phones, arcades, university, department, person, employee, all these are actually such objects which have many properties, and the many properties are of different data type. For example, a student has a name, a student has age, gender, address, program of study, and year, let's suppose. So you see, the name is a string, the age is maybe float, the gender may be character, address is a string, program of study is a string, year is integer. So you see, different data types, but these these different data types collectively represent one object, which is a student. So the object is one thing or one object, like student or mobile or cat, but it has many properties, many things, many values to represent one object. So if you want to represent one student, you need string, character, float, integer, multi data types will combine together, and then it represent one real word object, like the student example. Like for example, if we take one example as a student, like city, so the name is string, the age is float, the character, the gender is, let's suppose, female, address, program is, let's suppose, cognitive science, and is a second year student. So you see, different data types combined together, it represent one real world object. So the question is that how to store these different data types. If I want to store the name, so it will be a string variable, this will be a float, this will be character, string, string. So how to store? If I want to make an array, so the array will only maybe a string array, so I can only store string type of data. What about the float? What about the character? What about the int? If I want to make float array, it can only store age, float values. It cannot mix the character value, it cannot mix the string value. So how to store this information? It's actually a big challenge uh, to the built-in or primitive data type. The primitive data types are the int, float, string, etc. So to solve this problem and combine all these different data types into single entity, C++ introduced structure. Structure is such a data type that you can combine many different data types into a single unit. So actually, a structure is a mechanism which allow the programmer that, okay, you define, you can combine and you can decide how many different data types you can combine into a single entity. So it is like this. For example, now if we want to store the student, so this we can define by ourselves, like the word struct is compulsory struct, and then the structure that you are defining, if you are defining the student structure, you can, this will be the name, you can give any name, okay. Then in there, after that, a curly brackets, opening curly brackets and closing curly brackets, and then the semicolon. Inside this block, you can define as many data types as you want. And finally, all these data types will combine into one unit, which will be the student. Okay, so later on you can assign values to this uh, mm, uh, you can define variables and declare variables of this data type. The student will become a new data type now, and you can define like this, like for example, student Siti and let's suppose Zolaiha. So Siti dot name, you can access the individual members like this. These are called members of the structure. Okay, so ct.name, you can assign value, ct.age, assign value, ct.gender, assign value, address, program, year. Okay, and after that you can easily assign, you see, one structure to another structure. So all the values stored in this variable will be copied member by member to this variable. So the same values will be like this, and later on you can access and display like this, like cout city.name, maybe some space, and then city, sorry, I didn't change. So city.age or city.program, any member using the dot operator, you can access a structure. So structure is a mechanism, a way uh, to combine different data types to represent the real word object. So meaning to say that the primitive data type, the integer, float, double character, these variables cannot represent by itself the real word object, because in real word everything is an object. An object is a combination of multi properties, different values, like anything in this universe is actually a combination of multi values. So structure is the first approach which allow the programmers to combine different primitive data types, built-in data types, and define a new data type. So now here is again one another concept or another problem. For example, some people, uh, the word student is very general. Okay, some people will represent the student by let's suppose six properties: name, age, gender, address, program, and year, let's suppose. So we are representing here the student by six properties. Maybe someone will want to represent by many other properties. For example, they are adding mobile number, IC number. Okay, mm, and so on. You can add many properties. So meaning to say the same student can be represented by different people in different ways. So how to represent a general concept of a student? This is called abstract data type. Okay, so abstract data type means that yes, we know that the real world objects can be represented in many different ways, but what is the simple general way to represent? The simple general way uh, are the common general properties of something is called abstract data type. Okay, for example, look at the definition of abstraction. An abstraction is a general model of something. You see, general model of something, it is a definition that includes only the general characteristics of an object. For example, the term dog. So dog is an abstraction. So you see, dog is a quite general word. It defines a general types of animal. The term captures the sense of what all dogs are without specifying the detailed characteristics of any particular type of dog. So there are many different type of dog, but we are not going in the detail, but generally what general characteristics of dog. Similarly, general characteristic of mobile, then general characteristic of something else. For example, if you look at mobile, so maybe someone will represent mobile with brand, model, price, color, size, and year of release, let's suppose. But maybe someone else say, no, I want to add something else also. For example, I want to know the number of sims that this mobile can support, how much is its ram, how much is its storage. Maybe someone will say that, okay, I am interested in the processor also, what type of processor has been used, what type of camera has been used. So you see, there are many details are possible of everything, but a general representation of something is called abstract data type. Okay, so the general concept about something, and then represent that general concept through the built-in data types and combining into a single entity to define a new data type. This whole process is called data abstraction, and this is the beginning point of object oriented programming. Object oriented programming starts from data abstraction, and in the coming slides we will talk about in detail that how what are the main differences and main points of object oriented programming. But the main fundamental point that from where object oriented programming start is the data abstraction.